Space, the final frontier. We've been told it's empty, cold, silent, a vast, indifferent darkness stretching in every direction for billions of light years, broken only by the occasional flicker of a dying star. For over 60 years, the greatest minds on Earth have pointed their instruments at the sky. Billion-dollar telescopes, supercomputers the size of buildings, international teams of scientists dedicating entire careers to a single question: are we alone? And what they've found has been quietly buried in classified documents, in underfunded programs, in carefully worded press releases that tell you just enough to feel informed and not nearly enough to understand what is actually being discovered. This is not a film about conspiracy theories. This is a film about questions. Questions that credentialed scientists at major institutions have asked out loud and were told, in one way or another, to stop asking. What really happened on the moon? Why did we go 6 times and then simply stop? What is hidden inside the data of 5,500 confirmed planets beyond our solar system? And why do several of them violate the very models used to explain how planets form? What was that signal, that single extraordinary 72-second transmission received from deep space in 1977 that has never been fully explained to this day? And perhaps most importantly, why does the silence feel so deliberate? By the time this documentary ends, you will never look at the night sky the same way again. My name doesn't matter. What matters is what you're about to hear. Sit back, pay attention, and ask yourself at every step of this journey, why didn't anyone tell me this before? Because the answer to that question might be the most important answer of all. Chapter 1: The Wow Signal and the Silence After. August 15, 1977, Big Ear Radio Observatory, Ohio State University, Delaware, Ohio. It is a perfectly ordinary Tuesday morning. The observatory hums with the quiet efficiency of routine science. Banks of equipment record signals from deep space, a continuous stream of radio data that will later be reviewed by hand, by human eyes, looking for anything that stands out against the background noise of the cosmos. Dr. Jerry Emin is one of those human eyes. He is a volunteer. He is reviewing a paper printout of data from 3 days earlier, running his finger down columns of numbers and letters, each character representing a different intensity of radio signal received from a specific point in the sky. Most of the data looks the same: a low hiss, background radiation, the universe breathing, as it always does, in static. And then, in a sequence that would take less than a second to read aloud, something appears that changes everything. 6 E Q U J 5. In the encoding system used by Big Ear, numbers represented signal intensities from 1 to 9. Letters continued the scale, A equaling 10, B 11, and so on. The U character, the 4th letter of the sequence, represented a signal intensity of 30 times stronger than the background noise of deep space. Emin stared at it. He read it again. He checked his position on the printout against the telescope's known orientation. He calculated the timing. The signal had arrived on a frequency of 1420 megahertz, the precise frequency of hydrogen, the most common element in the universe. It was the frequency that scientists for decades had agreed would be the most logical choice for any intelligent civilization attempting to broadcast across interstellar distances. It was, in the language of radio astronomy, the universal channel, the one frequency that any species capable of building a radio telescope would know to use. The signal had risen from background noise, peaked at intensity 30, and faded back to nothing, in exactly the pattern you would expect from a fixed point in deep space passing through the telescope's field of view as the Earth rotated. Exactly 72 seconds, no more, no less. Emmons circled the sequence in red ink, and in the margin of the printout, he wrote a single word: "Wow." That printout now sits in a museum. The word is still there, in Emmons' handwriting. And for 47 years, it has represented the single most compelling potential evidence of non-human intelligence ever recorded by science. The signal was never heard again. Astronomers returned to that region of sky hundreds of times in the years that followed. Different telescopes, different frequencies, different times of year. Nothing, not a whisper, not a repetition, not a single echo of that 30-unit burst that lasted exactly as long as physics said it should if it came from a fixed point somewhere among the stars. The most common dismissive explanation is that it was a natural phenomenon, a pulsar perhaps, or some exotic form of stellar emission. But this explanation collapses under scrutiny. No known natural phenomenon produces a signal of that specific intensity, at that specific frequency, with that specific duration and rise and fall profile. The hydrogen line, 1420 MHz, is not a frequency at which natural astrophysical objects typically emit strong narrow-band signals. It is, however, exactly the frequency at which a civilization that understood basic chemistry would choose to broadcast. The second common dismissal is radio frequency interference. A satellite, an aircraft, a terrestrial transmitter accidentally reflecting off the ionosphere. But Big Ear's design used two separate feed horns, separated in time by about 3 minutes. Any local interference would have appeared in both horns. The wow signal appeared in only one. It came from a specific direction in space, from the constellation Sagittarius, to be precise, and it came from exactly where a radio telescope pointed at deep space should receive a signal, if that signal originated beyond our solar system. Jerry Amon himself spent years attempting to debunk his own discovery. He was, by all accounts, a cautious and rigorous scientist who did not want to overstate what he had found. And in the end, after exhausting every alternative explanation, he concluded, publicly, on the record, that the wow signal remains unexplained. NASA's response to all of this? They cut funding to SETI, the Search for Extraterrestrial Intelligence, in 1981, just 4 years after the most compelling potential signal from space in human history had been received. The official reason was budget constraints. The program was deemed speculative, unproductive, not a priority. Several astronomers who worked in the field at the time have given interviews in the decades since describing a different atmosphere, an institutional discomfort, a sense that the questions being asked were questions that certain people in certain positions did not want amplified by government funding and public attention. Dr. Frank Drake, the man who in 1960 conducted the first modern scientific search for extraterrestrial radio signals, and who later developed the famous Drake equation estimating the number of communicating civilizations in the galaxy, spent decades after the SETI funding cut attempting to keep the search alive through private donations and academic partnerships. He was largely successful, but always working against the current, always explaining to skeptical committees and indifferent bureaucracies why the search mattered. He died in 2022. The search continues, now funded almost entirely by private sources. The Allen Telescope Array, Breakthrough Listen, initiatives built on the conviction that the question is worth asking, even when the institutions that should be asking it have walked away. But here is what the press releases never featured. Here is what you will not find in the summary articles written about the wow signal in the years since. In the period surrounding August 1977, the Big Ear telescope logged not one, but 17 separate signal anomalies that deviated significantly from expected background noise. 17 events that did not fit the normal profile of cosmic radio emission. 13 of those 17 were never given a satisfactory natural explanation. 5 of those 13 occurred in the frequency range known among radio astronomers as the watering hole, a narrow band between the hydrogen emission line at 1420 MHz and the hydroxyl radical emission line at 1720 MHz. This band is significant because it sits in a region of the radio spectrum that is naturally quiet, shielded from most galactic noise, and therefore ideal for interstellar communication. It is called the watering hole because, as the analogy goes, it is where creatures from across the cosmic savanna might naturally gather to drink, to exchange signals, to listen, to reach across the void. 17 signals, 13 unexplained, 5 in the exact frequency range that the scientific community has, for decades, identified as the most logical place to look. And the government pulled the funding anyway. Ask yourself a simple question. If you were walking alone at night and you heard a sound that you could not explain, you would stop. You would listen harder. If you heard 17 such sounds and 13 of them remained unexplained, you would not go home. You would not decide the budget for listening was too high. You would stay, unless someone told you to leave. The wow signal sits in that space between what we found and what we were willing to pursue. It is not proof of extraterrestrial intelligence, but it is the most serious unexplained data point in the history of the search for it. And the response to it, the defunding, the dismissal, the deliberate quieting of the conversation, tells us as much about ourselves as it does about whatever might be out there. Chapter 2: The Black Hole They Didn't Want You to See. April 10, 2019, a Wednesday. Press conferences were held simultaneously in Brussels, Santiago, Shanghai, Taipei, Tokyo, and Washington, D.C. For the first time in human history, we saw a black hole. Not a simulation, not an artist's concept, a real photograph, constructed from petabytes of radio telescope data gathered by 8 observatories on 4 continents, all pointed at the same target on the same nights in April 2017. All synchronized to within a fraction of a nanosecond by atomic clocks. The entire planet Earth effectively transformed into a single telescope dish the size of a world. The target was the supermassive black hole at the center of the galaxy M87, a galaxy 55 million light-years away, home to a black hole 6.5 billion times the mass of our Sun. The image that appeared on screens around the world showed a bright, asymmetric ring of glowing orange gas, the accretion disk, superheated material swirling toward the event horizon at a significant fraction of the speed of light, and at its center, a dark, circular shadow, the black hole itself, the point of no return, the place where gravity becomes so intense that not even light can escape. The world celebrated. It was called one of the most significant images in the history of science. Scientists who had spent careers working toward that moment wept openly at the press conferences. It deserved every word of praise it received. But here is what the press conferences did not dwell on. The image did not match the predictions. Not entirely, not in the ways that mattered most to the physicists who spent the following months analyzing what had actually been captured. General relativity, Einstein's theory of gravity, published in 1915 and confirmed by experiment after experiment for over a century, makes specific predictions about what the shadow of a black hole should look like. The size of the shadow relative to the mass of the black hole, the shape of the bright ring surrounding it, the degree of asymmetry caused by the rotation of the black hole, and the relativistic beaming of light in the accretion disk. Some of those predictions were confirmed beautifully. The shadow was there, the ring was there, the basic structure matched the general expectations of the theory. But the brightness asymmetry was stronger than expected. The structure of the relativistic jet, the beam of plasma and energy that M87's black hole fires outward into intergalactic space for thousands of light years, did not connect to the accretion disk in exactly the way the leading models predicted. And the precise shape of the photon ring, the ring of light created by photons that have orbited the black hole before escaping, showed features that have prompted years of follow-up analysis and model revision. None of this means Einstein was wrong. General relativity remains the best description of gravity we have. But it does mean our models are incomplete. And in physics, incomplete models are not a minor inconvenience. They are the frontier. They are where the next revolution is hiding. The information paradox is the deepest version of this frontier. Stephen Hawking first articulated it clearly in 1974. The argument goes like this: quantum mechanics, our theory of the very small, of particles and fields and the behavior of matter at the most fundamental level, contains an absolute prohibition. Information cannot be destroyed. The quantum state of a system can be scrambled, transformed, transferred, but it cannot simply cease to exist. This is not a philosophical preference, it is a mathematical requirement built into the foundations of the theory. Black holes, on the other hand, appear to violate this requirement. When matter falls into a black hole, it crosses the event horizon, the point of no return, and from that moment, nothing about it can be observed from the outside. The information it contained, its quantum state, its history, every detail of what it was, appears to be lost, swallowed, gone.
This would be acceptable, perhaps, if black holes existed forever. But Hawking himself discovered they don't. In 1974, he calculated that black holes slowly emit a faint thermal radiation, now called Hawking radiation, caused by quantum effects near the event horizon. This radiation carries energy away from the black hole. Over astronomically long timescales, longer than the current age of the universe for most black holes, they gradually lose mass and eventually evaporate completely. And when they do, what happens to all the information that fell in? If it's truly gone, if the final evaporation of a black hole erases the quantum states of everything that ever crossed its horizon, then quantum mechanics is violated. One of the most precisely tested theories in the history of science would be fundamentally wrong. If it's somehow preserved, encoded in the Hawking radiation, scrambled, but in principle recoverable, then we need to understand the mechanism by which information escapes from behind an event horizon, which means understanding physics that we do not yet possess. Hawking spent the final decades of his life on this problem. He proposed solutions. He revised them. He proposed them again in different forms. He revised them again. The last major paper on the subject bearing his name was published after his death, completed by colleagues who had been working with him in the final months of his life. He died without resolving it. The physicists who have taken up the problem since have produced proposals of stunning mathematical sophistication: the holographic principle, the firewall paradox, the island formula, the page curve. Each one reveals something true about the problem. None of them fully solves it. And at the center of the Milky Way, 26,000 light-years from the planet you are sitting on right now, there is a black hole 4 million times the mass of our Sun. It is called Sagittarius A star. We photographed it in 2022, 3 years after M87. The image was harder to capture. Our galactic center is obscured by clouds of gas and dust, and Sagittarius A star is smaller and more variable than M87, its accretion disk flickering on timescales of minutes rather than days. But it is there. It has always been there. The entire Milky Way, every star, every planet, every atom of gas and dust in this galaxy orbits around it. Our Sun takes approximately 230 million years to complete one orbit. In the 4.5 billion years of Earth's existence, the planet you are on has circled a black hole approximately 20 times. You have been orbiting a void your entire life. The black hole at the center of things is not a metaphor, it is a fact. It is the gravitational anchor of everything you have ever known. The question is not whether black holes are real, we have seen them. The question is what they mean, what they tell us about the nature of reality, about the structure of space-time, about what happens at the places where our best equations break down completely. And those are questions that the news cycle moved past in 3 days. Chapter 3: Exoplanets, 5,500 worlds, and the ones they won't discuss. Let us talk about scale. Real scale. Not the kind of scale that feels manageable, that fits inside a diagram or a comfortable analogy. Real scale. The observable universe is approximately 93 billion light-years in diameter. Within that volume, there are an estimated 2 trillion galaxies. Our galaxy, the Milky Way, contains somewhere between 100 billion and 400 billion stars. The most recent estimates, based on data from the Gaia Space Telescope, suggest the higher end of that range is closer to the truth. Around those stars orbit planets, many planets. Possibly most stars have them, and among those planets, a significant fraction, the precise number is debated but the order of magnitude is not, orbit within the habitable zone of their star, the region where liquid water, and therefore life as we understand it, could exist. The Kepler Space Telescope was launched in March 2009. Its mission was simple in concept and extraordinary in execution. Stare at a single patch of sky containing approximately 150,000 stars and look for the faint periodic dimming that occurs when a planet passes in front of its star as seen from our vantage point. The transit method. Patient, precise, relentless observation. That patch of sky was about 115 square degrees, roughly the size of your fist held at arm's length against the night sky, less than 1/300th of the total sky. From that tiny window, in 9 years of operation before its fuel ran out and it was retired in October 2018, Kepler confirmed the existence of 2,662 planets beyond our solar system. It also flagged nearly 4,000 additional candidates awaiting confirmation, objects that showed the signature of a transiting planet but had not yet been verified by follow-up observation. From one small patch of one galaxy. If we extrapolate Kepler's results to the full sky, which astronomers do with appropriate statistical caution, the numbers become almost impossible to hold in mind. There could be 40 billion Earth-sized planets in the habitable zones of Sun-like stars in the Milky Way alone. Not gas giants, not ice worlds, Earth-sized planets in the zone where water flows, 40 billion of them, in one galaxy out of 2 trillion. The math does not care about your comfort level. Now, here is where it gets interesting. Among those 5,500 confirmed exoplanets, the number as of this filming, there is a category that planetary scientists have quietly labeled as dynamically anomalous. These are worlds that should not exist, not as a matter of opinion or philosophical preference, but as a matter of mathematics. They violate the models used to describe how planets form. The most common example is the hot Jupiter. These are gas giant planets, worlds comparable in size to Jupiter or larger, that orbit their host stars at a distance of less than 1/10 of an astronomical unit. To put that in perspective, Mercury, the innermost planet in our solar system, orbits the Sun at approximately 4/10 of an astronomical unit. Hot Jupiters orbit closer than that, far closer. In some cases, they complete an orbit in less than 24 hours. At those distances, the temperature on these worlds exceeds 1,000, 2,000, sometimes 3,000 degrees Celsius. The tidal forces exerted by the host star are immense. The radiation environment is lethal to any atmospheric chemistry we understand. And yet, hundreds of them exist, confirmed, photographed, documented. The standard explanation for hot Jupiters is planetary migration, the idea that these worlds formed farther out in their solar systems, in the cooler regions where gas giants typically assemble, and then gradually spiraled inward over millions of years due to interactions with the protoplanetary disk. It is a reasonable hypothesis. It has mathematical support, but it is also, in the words of several planetary scientists, deeply unsatisfying. Because the timescales and conditions required for the migration to produce what we observe are themselves on the edge of what our models can produce. Then there is Kepler 452b. In July 2015, NASA held a press conference announcing the discovery of what they called Earth's closest twin. Kepler 452b orbits a star called Kepler 452, located approximately 1,400 light-years from Earth in the constellation Cygnus. The star is a G-type star, the same classification as our Sun, slightly older, slightly larger, slightly brighter. The planet is approximately 60% larger than Earth. It orbits in the habitable zone. Its year, one complete orbit, lasts 385 days, almost identical to our own. And it is approximately 6 billion years old. NASA described it as a larger, older cousin of Earth. The comparison was made with appropriate scientific hedging, but the number, 6 billion years, was mentioned briefly, and then the press conference moved on to more photogenic details. 6 billion years. Our solar system is 4.5 billion years old. Earth itself is 4.5 billion years old. The first simple microbial life on Earth appeared approximately 3.8 billion years ago. Complex multicellular life, animals in the broadest sense, appeared approximately 600 million years ago. Human beings in our current anatomically modern form have existed for approximately 300,000 years. Our entire history, from the first shaped stone to the device you are watching this on, fits inside 300,000 years. Kepler 452b has had 6 billion years, 1.5 billion years more than our entire solar system has existed. If the conditions on Kepler 452b are anything like the conditions that produced life on Earth, and we have no reason to assume they are not, then whatever process of biological and potentially cognitive evolution has been occurring there has had 6 billion years to run. The implications are not subtle, but they were not the focus of the press conference. The case that makes astronomers most visibly uncomfortable, the one that produces the longest pauses in interviews, the most careful phrasing, the most frequent requests to move on to a different question, is a star approximately 1,485 light-years away in the constellation Cygnus. Its formal designation is KIC 8462852. Most people call it Tabby's star, after Dr. Tabitha Boyajian of Louisiana State University, who led the team that first analyzed its strange behavior in 2015. Tabby's star dims. This is not unusual. Thousands of stars dim periodically as planets transit in front of them, and Kepler was designed to detect exactly this kind of dimming. But Tabby's star dims in ways that make no sense under any natural model currently available to science. Normal planetary transits produce small, regular, predictable dips in brightness, typically less than 1%, always the same depth, always the same duration, always spaced at consistent intervals corresponding to the planet's orbital period. Tabby's star dims by amounts ranging from less than 1% to more than 22%. The dips are irregular in timing, asymmetric in shape, meaning the star dims gradually but brightens back unevenly, and vary in depth from event to event. Over the period of Kepler's observation, the star also showed a long-term secular dimming of approximately 3%, a slow and steady decline in overall brightness over years. No known natural phenomenon, no cloud of comets, no ring of dust, no swarm of asteroids, no stellar variability mechanism fully explains all of these features simultaneously. Individual models can explain some of the observations. None of them explain all of them. Dr. Boyajian's original paper, published in the monthly notices of the Royal Astronomical Society, listed every natural explanation the team could generate, evaluated the evidence for and against each one, and concluded, in language that was measured but unmistakable, that no satisfactory natural explanation had been found. The paper also noted, as one of several hypotheses that could not be ruled out on the basis of existing data, the possible presence of large artificial structures in orbit around the star. That sentence, in a peer-reviewed scientific paper in one of the most respected astronomical journals in the world, received approximately 48 hours of media coverage, was treated largely as a curiosity rather than a finding, and then was allowed to recede from public conversation. The star is still dimming. The explanation is still not been found. The Fermi paradox. Enrico Fermi was one of the great physicists of the 20th century, the architect of the first nuclear reactor, a Nobel laureate. In 1950, during an informal lunch conversation with colleagues at Los Alamos, he asked a question that has since become one of the most discussed problems in science. Where is everybody? The logic is straightforward. The universe is approximately 13.8 billion years old. Our galaxy is approximately 13 billion years old. Stars capable of hosting habitable planets have existed for most of that time. If even a tiny fraction of the billions of planets in the habitable zones of those stars produced technological civilizations, and if even a tiny fraction of those civilizations survived long enough to develop interstellar communication or interstellar travel, the galaxy should, by any reasonable calculation, be full of evidence of their existence: signals, probes, artifacts, visitors, something. And yet we detect nothing. The sky is silent. The universe, as far as our instruments can determine, is empty of any signal that cannot be explained by known natural processes. This is the Fermi paradox, and it has no comfortable resolution. The explanations that have been proposed over the decades fall into two broad categories. Either the emergence of technological civilizations is so rare, despite the billions of opportunities, that we are genuinely, improbably alone. The first, the only, a cosmic accident so unlikely that it has not repeated anywhere in the observable universe. Or we are not alone, and the silence has a different explanation. Perhaps civilizations routinely destroy themselves before reaching the point of interstellar communication. Perhaps the universe is full of dead planets and burnt-out civilizations that never made it past the equivalent of our 20th century. Perhaps the signals are there, and we are not yet sophisticated enough to recognize them. Or, perhaps, and this is the possibility that the Fermi paradox makes logically inescapable if the first two options are rejected, something about the universe systematically prevents civilizations from being heard. The Great Silence, as it is sometimes called, is not evidence of emptiness. It is a fact that demands explanation, and we have not found one that satisfies. Chapter 4. Apollo's Hidden Files. July 20th, 1969, 8:17 in the evening, Eastern Daylight Time. The Eagle lands. In a shallow crater in the Sea of Tranquility, 400,000 kilometers from Earth, a spacecraft designed and built by human beings touches the surface of the Moon. 2 human beings are inside it. One of them, Neil Armstrong, will climb out 4 hours later and place his left foot on the lunar soil. He will say 12 words that are among the most famous in the English language. It is, by any measure, one of the greatest achievements in the history of our species. And the mission generated far more information than the world was ever shown. Let us be precise about this, because precision matters here. The Apollo program, in its 6 successful lunar landing missions, produced thousands of hours of audio recordings, hundreds of thousands of photographs, miles of film footage, and reams of technical data that have been processed, analyzed, stored, and, in some cases, reported as missing. The television footage broadcast to the world during the Apollo missions was selected. This is not a secret. NASA made deliberate choices about what to transmit to Earth in real time, constrained by bandwidth, by technical limitations, and by the practical realities of operating in an environment where everything was happening for the first time. The transcripts of communications between the astronauts and mission control were released in the decades following the missions. They run to thousands of pages. They are fascinating, technical, and, for the most part, exactly what you would expect from professional test pilots and engineers carrying out an extraordinarily complex mission under conditions of extreme physical and psychological stress. They also contain gaps, moments where the official record notes only static or crosstalk, periods where the transcript format shifts in ways that suggest editing, sections where the timing between exchanges does not match the expected rhythm of voice communications at lunar distance. These gaps have been noted by researchers who have spent years studying the transcripts. They have been attributed to technical limitations, to the imperfection of recording equipment in 1969, to the difficulty of capturing every word spoken in a complex operational environment. These are reasonable explanations. They may be the correct explanations. But in 2012, NASA announced that 40 rolls of original Apollo mission footage, magnetic tape recordings from multiple missions, could not be located. Not classified, not restricted, not moved to a different archive, simply not there. The official explanation was that the tapes had likely been degaussed, magnetically erased, and reused during a period in the 1970s and 1980s when NASA, like many institutions, was managing its media library under budget constraints and did not fully appreciate the historical value of original mission recordings. The tapes were, at the time, considered working copies of data that had already been transferred to other formats. This explanation is plausible. It is also, if true, one of the most consequential acts of institutional negligence in the history of recorded history. The highest resolution footage of humanity's first steps on another world erased to save money on magnetic tape. Edgar Mitchell was the sixth human being to walk on the moon, Apollo 14, February 1971. He spent 33 hours and 30 minutes on the lunar surface. After returning to Earth, Mitchell pursued graduate studies at MIT, earned a doctorate in aeronautics and astronautics, and spent the rest of his life, he died in 2016, giving interviews in which he said, with increasing directness as the years passed, that unidentified aerial phenomena were real, were being observed by the military and intelligence communities, and were being actively kept from public knowledge. Mitchell was careful. He was precise. He did not claim personal sightings. He spoke in terms of what he had been told by sources within the defense and intelligence establishment. Sources he described as credible, as direct, as specific. He said these things in television interviews, in recorded lectures, on the record, repeatedly, and they were treated consistently as the harmless eccentricity of a brilliant man who had perhaps been changed by the experience of standing on another world. The dismissal of Mitchell's statements relied heavily on the implicit suggestion that the experience of spaceflight, the overview effect, the psychological impact of seeing Earth as a small, fragile sphere against infinite blackness, could cause a person to develop beliefs that were sincere but untethered from reality. This is a convenient explanation. It is also, given what came next, increasingly difficult to sustain. In December 2017, the New York Times published a front-page investigation that changed the terms of the conversation permanently. The article revealed that the United States Department of Defense had operated a classified program called the Advanced Aerospace Threat Identification Program, ATIP, from 2007 to 2012. Funded at $22 million per year from the defense budget, dedicated to the collection and analysis of unidentified aerial phenomena encountered by military personnel. The program's existence had not been publicly acknowledged. Its findings had not been publicly released. Its director, Luis Elizondo, a former career intelligence officer, had resigned in October 2017, submitting a letter to then Secretary of Defense James Mattis, in which he stated that the program's findings were not being given the serious attention they deserved, and that excessive secrecy and internal opposition were preventing important national security information from reaching appropriate decision-makers. Elizondo went public. He gave interviews. He described, in careful and credible language, a pattern of encounters between military pilots and objects that performed maneuvers inconsistent with any known aircraft or natural phenomenon. Objects that appeared without radar signature. Objects that accelerated from stationary to hypersonic speed in seconds. Objects that made right-angle turns at velocities that would reduce any human occupant to biological material. 3 videos were released simultaneously with the Times investigation. They had been recorded by Navy FA-18 pilot targeting systems. They showed, in the slightly blurry infrared imaging characteristic of such systems, objects moving in ways that the pilots in the cockpits, highly trained, experienced aviators whose profession is the identification of what they are looking at, could not explain. One of the pilots, Commander David Fravor, gave extensive on-the-record interviews describing his encounter. He was not vague. He was not hesitant. He described, in the tone of a professional giving a technical debrief, an object that he watched descend from 80,000 feet to just above the ocean's surface in seconds, hover briefly above a disturbance in the water, and then accelerate away faster than anything he had ever seen, disappearing from visual range in an instant. Fravor was not dismissed as eccentric. He was not described as having been changed by extraordinary experiences. He was a Navy commander with 18 years of service and an exemplary record. And what he described was, by any technical assessment, a vehicle performing maneuvers that no vehicle we know of can perform. The Pentagon confirmed the videos were authentic. The Senate Intelligence Committee held classified briefings. A new office, the Airborne Object Identification and Management Synchronization Group, later renamed the All-Domain Anomaly Resolution Office, was established within the Defense Department to manage incoming data on unexplained aerial encounters. We went to the moon in 1969. We went back 5 more times, the last visit in December 1972, and then we stopped. 50 years, no human being has been beyond low Earth orbit since the final Apollo mission. The official explanation is that the Apollo program was a product of the Cold War space race, a massive mobilization of national resources driven by geopolitical competition with the Soviet Union. Once that competition was won, the political will and the budget for continued lunar exploration evaporated. The Saturn V rocket that carried the Apollo missions was expensive, complex, and had no peacetime constituency. The engineers who built it were aged and eventually gone. The program was dismantled. This explanation is historically accurate. It is also, when examined closely, remarkable. The Saturn V remains, by some measures, the most powerful rocket ever successfully flown. Its first stage produced 7.6 million pounds of thrust. No rocket currently in service matches it. The vehicle that carried human beings to the moon was designed and built by a generation of engineers, many of them trained in wartime Germany and post-war America, who worked with slide rules and mechanical calculators.
We have not rebuilt it. For decades, NASA did not even retain the manufacturing documentation for some of its components. Engineers who joined the space program in later years have described the experience of attempting to reconstruct Saturn V-era technology as archaeological, piecing together how things were done from surviving hardware and the memories of aging men. The word that several historians of the space program have used carefully is allowed to lapse. The knowledge was allowed to lapse. The capability was allowed to lapse. Whether this was the result of budget priorities, institutional inertia, political indifference, or something more deliberate, that is a question the historical record does not answer clearly. What it does answer clearly is this. In 1972, human beings could travel to the moon. In 2024, we are working, expensively and slowly, to do it again. Buzz Aldrin, the second human being to walk on the moon, a retired Air Force colonel, a mechanical engineer with a doctorate from MIT, has spent the decades since Apollo 11 in an interesting position. He is simultaneously one of the most celebrated figures in American history and one of the most carefully managed. His public statements about his Apollo experience have always been precise, controlled. He does not speculate. He does not embellish. He does not, in the way that Edgar Mitchell did, make broad claims about what he was told in private briefings. But in a 2005 documentary interview, when asked directly about something unusual observed during the journey to the moon, Aldrin described, briefly, matter-of-factly, in the tone of a man reporting a technical observation, an object outside the window of the command module during the translunar coast, an L-shaped object that appeared to track the spacecraft for a period before disappearing. He said, "We decided not to report it to Houston.
The documentary moved on. The interviewer did not follow up. The moment was noted by researchers and largely ignored by the mainstream press. We decided not to report it to Houston. From the second man to walk on the moon. Chapter 5. The truth is out there, or is it in here? We have come a long way tonight. We began with a signal received in the summer of 1977, a signal that no one has ever explained, from a direction in the sky that has been searched hundreds of times since in silence. A signal that was followed within years by the defunding of the program that might have found it again. We looked at the first photograph of a black hole, a genuine triumph of human ingenuity that also revealed, quietly, that our best equations do not fully describe what we are looking at, that the universe at its most extreme behaves in ways our models cannot yet account for. We examined 5,500 worlds beyond our solar system, worlds that shouldn't exist by our own models. A star whose dimming pattern has never been satisfactorily explained. A 6-billion-year-old planet in a habitable zone, sitting in silence 1,400 light-years away, with 1.5 billion more years of history than our entire solar system possesses. And we looked at the moon missions, at the missing tapes, at the classified defense program that confirmed military pilots were encountering objects performing impossible maneuvers. An astronaut who chose in the moment not to report something to mission control. None of this is invented. Every fact in this documentary is sourced. The WOW signal is real. The ATIP program is real and has been confirmed by the Pentagon. The missing Apollo tapes are documented. Kepler 452b is real. Tabby's star is real. Edgar Mitchell's interviews are on the record. The question is not whether these things happened. The question is what we are supposed to do with them.
There is a version of this story in which every anomaly has a mundane explanation that we simply haven't found yet, in which the WOW signal was a rare but natural astrophysical event that happened to mimic the expected profile of an artificial transmission, in which the AATIP program was a legitimate national security effort that found conventional explanations for unconventional aircraft, in which the missing tapes were lost through bureaucratic negligence rather than deliberate action, in which Buzz Aldrin saw a piece of the launch vehicle hardware drifting alongside the spacecraft. Maybe all of that is true. Science demands that we hold the mundane explanation as the default, that we require extraordinary evidence for extraordinary claims, that we do not leap to conclusions that outrun the data. But science also demands something else. It demands that we do not stop asking, that we do not accept maybe when the data is genuinely unresolved, that we do not allow institutional convenience, budget pressure, or the discomfort of powerful people to determine which questions are considered worth pursuing. The history of science is the history of questions that were considered too strange, too uncomfortable, or too dangerous to ask, until someone asked them anyway. The Earth orbiting the Sun, the germ theory of disease, the age of the universe, the existence of the unconscious. Every paradigm we now take for granted was once a heresy. We are a species defined by curiosity, by the drive to look further than our eyes can reach, to listen for signals our ears cannot detect, to build instruments that extend our senses to the edge of the observable universe and ask, what is out there? We built the Big Ear telescope and pointed it at the sky because we could not accept that the silence was the answer. We built the Kepler telescope and stared at 150,000 stars because we needed to know if there were other worlds.
We built the Event Horizon Telescope, an instrument the size of the Earth itself, because we needed to see the unseeable. That drive is not naive. It is not unscientific. It is the most human thing we do. The cover-up, if that is what it is, does not belong only to governments and agencies and classified programs. It belongs to all of us. Every time a story like this fades from the news cycle in 48 hours, every time a credentialed scientist says something extraordinary and we allow it to be dismissed without follow-up, every time we accept the budget cut without asking what we stopped looking for when the money ran out. The cosmos is ancient. It has been here for 13.8 billion years. It will be here, in one form or another, long after the last government classification expires and the last press conference is forgotten. The WOW signal has been sitting in the archives for 47 years, circled in red ink, waiting. Tabby's star is still dimming. 5,500 planets orbit distant suns in our galaxy alone, and we have characterized the atmospheres of fewer than 100 of them. 40 billion worlds sit in habitable zones, in silence, or perhaps in a silence that is something other than silence, and we simply haven't listened long enough, or carefully enough, or with the right instruments pointed in the right direction. The only honest answer to the question of what is out there is we don't know. Not yet. Not with the resources we have committed, not with the attention we have sustained. But we could know. That is the thing that should keep you awake at night, not the fear of what might be out there, but the possibility that the answer is within reach, and we have been, for reasons that are not entirely scientific, choosing not to reach for it. Look up tonight. Find a dark patch of sky away from city lights if you can. Look at the stars. Each point of light is a sun. Most of those suns have planets. Some of those planets, by every statistical measure we possess, should have produced life. Some of that life, given enough time, should have produced minds that look up and wonder. The universe is not empty. It is full of questions that have not yet been asked loudly enough. This has been the Cosmic Cover-Up. The search continues. Thank you for watching. There is one more thing that deserves to be said. We live in an age of information. More data is generated every day than was produced in the entire history of humanity before the digital age. We carry devices in our pockets that have access to virtually the sum total of recorded human knowledge. We are, by any historical standard, the most informed generation that has ever lived. And yet, we know less about what is happening in the skies above us in the serious and systematic scientific sense than we did 40 years ago. The funding for SETI is smaller in real terms than it was before the government pulled out in 1981. The number of radio telescopes dedicated to the search for extraterrestrial intelligence is smaller. The institutional commitment from governments, from major research universities, from the agencies whose explicit mandate is the exploration of space, is smaller. This is not an accident of budget mathematics. It is a choice made repeatedly over decades by people in positions of authority who understood what they were choosing. The question is why? Some of the answers are ordinary. Science funding is competitive. Space exploration is expensive. The search for extraterrestrial intelligence produces no immediate practical return. Politicians who must answer to voters find it difficult to justify millions of dollars spent listening for signals that may never come. These are real constraints. They are not invented, but they do not fully explain the pattern. Because the pattern is not merely one of underfunding, it is one of active diversion. The ATIP program existed for 5 years, spent more than $100 million, and its findings were kept classified. Not unanalyzed, not unimportant, classified. Meaning that somewhere in a building to which most of the people in this documentary did not have access, people were reading reports about encounters that the public was told were not worth investigating. That is not neglect. That is decision-making. The moon. Consider the moon again for a moment. We went. We left. We built a capability that no generation since has matched, and then, not gradually, not reluctantly, but with what in retrospect looks almost like purpose, we dismantled that capability and allowed it to dissolve into institutional memory. The engineers who designed the Saturn V are dead. The companies that manufactured its components have been reorganized, merged, dissolved. The specific metallurgical processes, the specific manufacturing tolerances, the specific solutions to the thousands of engineering problems solved between 1961 and 1969, many of these exist now only in the surviving hardware and in the fading memories of people who are no longer here. We went to another world. We left. We forgot how we did it. In the history of technology, this has essentially never happened before. Capabilities are lost when civilizations collapse, when catastrophes interrupt the transmission of knowledge, when wars destroy the infrastructure that makes complex technologies possible. They are not typically lost by the deliberate policy of stable, prosperous nations that have every reason to preserve them. And yet, perhaps the most important thing this documentary can leave you with is not a specific claim about what is being hidden, or by whom, or to what end. The honest answer is that we do not know. The evidence points toward deliberate choices, deliberate suppressions, deliberate redirections of attention and resources. But the full picture, the why, the who, the what exactly, remains, appropriately, in the realm of the unknown. What we do know is simpler, and in some ways more disturbing. We are a species capable of photographing a black hole 55 million light-years away. We are a species capable of landing a spacecraft on a moving comet. We are a species capable of sending a probe beyond the edge of our solar system into interstellar space, carrying a golden record with the sounds of Earth in case anyone finds it. We are capable of all of this, and we have chosen, repeatedly and deliberately, to invest less in the search for answers to the most fundamental question we have ever asked: are we alone? Than we spend in a single afternoon on other priorities. That is the cover-up that no classification can hide. It is not in the files, it is in the budget. It is in the attention we pay and the attention we withdraw. It is in the questions we allow to be answered and the questions we allow to fade. The universe is patient. The signals, if they are there, have been traveling for millions of years. They can wait a little longer. The question is whether we can. Keep looking up. Keep asking. Do not let the silence be the answer. This has been the Cosmic Cover-Up. Good night.